Today we're going to be looking at absolute value equations. Tomorrow we're going to be looking at the inequalities. So that's for 2.6b. So we're looking quickly at the distance definition of absolute value. Then we're going to be looking at the most common case, so the absolute value equals a number. And then some that require some rewriting. And then a couple of special cases. So first off, the distance definition of absolute value. Absolute value is literally meaning the distance from zero, from some point to zero. For example, if the absolute value of x is 5, then we're saying what are the points that are 5 units from zero? Well, negative 5 is 5 units from zero, and positive 5 is 5 units from zero. So those would both be solutions to that equation. So anytime you're dealing with an absolute value equation, with an x inside the absolute value, you're going to have two possibilities, when it equals a positive number and when it equals a negative number. So for example, if you have absolute value of 3x minus 4 equals 11, this expression is 11 units from 0. So that either has to come out to be positive 11, or it needs to come out to be negative 11. And then you would just solve both equations. Add 4 to both sides. Divide by 3, and x is 5. Don't assume that the other solution is negative 5. Just because we changed 11 to negative 11 doesn't mean the solution just changes signs as well. If we add 4, we in fact see this is adding up to be the same. Divide by 3. And since 7 isn't divisible by 3, we just leave that as a fraction. So we have two answers, negative 7/3 and 5. Example 2 is a case where we have something that's not just absolute value. Notice over here, we had absolute value equals a number. That's why we can separate it out. But we can't say this is exactly 15 units from 0, because we have a plus 4 that's on the outside there that's kind of thrown it out of whack. So we need to get that one moved over first. And then we can see that that expression is actually 11 units from 0, not 15. Now we can separate it out into two equations. Positive 11, negative 11. Notice I didn't just solve this first one and then say our answer is positive negative, because that doesn't work. Subtract 2. 3a equals 9. Divide by 3, and we say a can be positive 3. Over on this side, if we subtract 2, make sure you're careful with these negatives. Negative 11 and the negative 2 is negative 13. If it helps, you can check those with the calculator. Divide by 3. And again, since 13 doesn't divide evenly by 3, I'm just going to leave that as an improper fraction. So our two solutions, negative 13 over 3 and 3. So you're probably thinking to yourself, we're always going to have two solutions, right? Not always. There is a special case we're going to get to here in a minute. All right, our first special case we're looking at is if we have absolute value on both sides. If both sides are completely encased in absolute value, we do it the same way. We just pick one of them to set as a value that is a distance from 0. So for example, we could say this one is the distance from 0. So we make a positive version of it and a negative version of it. So since both sides are, this is an absolute value, this is an absolute value, we're going to have 4r minus 1 equals positive 3r plus 5. Or the other option, we keep the one side the same and take the negative of the other side. And honestly, it doesn't matter which side we keep the same. as long as we keep one side the same and change the other side to negative. It's always easier to keep the right side, or remember to do the same way each time. All right, solve for r on the left. We subtract 3r. We get r minus 1 equals 5. And we add 1 and see that r equals 6. On this side, we do need to distribute this negative. You could put a 1 out front first if you need to. 4r minus 1 equals negative 3r minus 5. So to get our r's on the same side this time, we're going to have to add 3r. And then add 1 to both sides. And divide by 7. Since that is not divided evenly, we just say that r equals negative 4/7. So again, we've got two solutions. Negative 4/7 and 6. And if you weren't sure about these, you can plug them back in and it should give you an equivalent statement. All right, let's now look at some of our special cases. If you're talking about an absolute value, then we're talking about a distance from 0. Distances can never be negative. So if you ever get an absolute value equal to a negative number, then it is no solution. Because you can't take an absolute value and get a negative number. And there's only one case that gives you one solution, because there's only one number that the positive and negative are the same value. And that's 0. So if you have it equal to 0, then there's only one solution. Every other time, there will be two solutions. So if it's a negative, no solution. It's equal to 0, there's one solution. And any other number, you would have two solutions. So we look at A. Don't even start solving it, breaking up into positive and negative, because this is negative. Absolute value can never be negative. No solution. This one, this is supposed to be absolute value. You could separate out into equations. 1/4 x minus 3 equals 0. And 1/4 x minus 3 equals negative 0. But isn't negative 0 and 0 the same thing? So we just throw out that extra negative 1. When I solve two problems, I'm going to give you the same answer. And solve this equation. We're going to add 3 to both sides. And anytime you need to cancel out a denominator and a fraction, we multiply by it. So I'm going to multiply both sides by 4. Here we see we get 12. Here the 4's cancel. 1 times x is just x. And we see x is 12. So there's just one solution this time. And that's because we had it equal to 0. And that's all for today's lesson. Make sure you bring your book, ready to work tomorrow in class.